Alright, so today we are going to be talking about arithmetic sequences, and this will be lesson 5.1. So virtual, let me know, you can hear, you can see everything that's going on. Thank you. Alright, so I'm going to read this little paragraph here. Sequences represent a list of numbers in a specific order. Each number in the sequence is called a term. Because sequences are an ordered list of numbers, each number sits in a certain position within the sequence. Each term's position can be referred to as the nth term. Sequences usually have patterns or rules, which are ways to describe the nth term of the sequence. The rule for the following sequence can be represented as a sub n is equal to 2n plus 1. So looking at this sequence, 3, 5, 7, what are you noticing the pattern should be? What'd you say? Yeah, it's increasing by how much? 2 each time, right? So each time we're adding 2.
Oh my god, I remember these.
You remember these?
I don't like them.
Maybe you'll like them this time. So each time you're adding 2. So an arithmetic sequence is defined by a sequence that you're either adding some number, the same number over and over again, or you're subtracting the same number over and over again. That's what defines an arithmetic sequence. Now, there are other types of sequences called geometric sequences where you're multiplying or dividing, but arithmetic is addition and subtraction only, okay? So I want to make sure you guys understand that. So there are two types of arithmetic sequences. There are finite and infinite. So finite is the opposite of infinite, meaning that it ends, it terminates. So a finite sequence has an n number, and an infinite sequence, as you can see, so you notice how it goes 4, 8, 12. It doesn't have a terminating number, so we don't put an n number at the end of it. Because we don't know, it's going on forever. So there's no point in putting a number there, because it never ends. Okay, so let's talk about how we define an arithmetic sequence and some terminology we use for it. So there are two types of rules you can use. We have what we call an explicit rule and a recursive rule. Explicit rule is like, you know, the one-size-fits-all formula that works for everything, okay? A recursive is a specific formula that only works if you have very specific information. So if you have the choice between an explicit or a recursive formula, explicit is always going to give you more information, going to be more useful, more applicable, okay? Now, there are a few types of important things you need to know about these formulas and the terminology and the variables, what they mean. So, the first term of a sequence is always defined by a sub n. That's how we say it. You know, in chemistry, you have the little subscripts. It's the same in math. So this number here, we call this a sub n, and this is our first term. You don't have to write this if you don't want. I'm just trying to make sure I talk about this. So that's what our first term is called. This right here, a sub n, is what we call the nth term. Okay, the nth term. So you can think of n almost as a variable. It's not quite a variable, but it's basically a placeholder for something that you're going to be plugging in. Okay, because we're going to be trying to figure out what term we're talking about. So we're talking about the nth term. I'm talking about some term, but I don't know which one. Now, whatever term you're trying to find, if you want to find the 8th term, you're going to be plugging in 8 for n into the formula. Okay, and then the ones that you'll see sometimes are a minus or n minus 1, a sub n minus 1. Any ideas what this would be? It would be the term directly before the nth term, right? Because if I wanted just to ask what was your age before this, directly before the age you are now, what would you do to your age? Subtract 1. So if you want to find the term directly before the nth term, you would subtract 1. So term before nth term. Okay? And on the contrary, if we have a sub n plus 1, that's the term what?
After.
Good. Term after the nth term. And you could kind of keep going with this. You could have a sub n plus 2, a sub n plus 3. That's 2 terms after the nth term, 3 terms after the nth term. So I just want you to understand that notation. So that's an important part of the notation. And the next important part is what we call the arithmetic difference, okay? Or also known as the common difference. That's usually how I refer to it. So The common difference is basically the number that you're either adding or subtracting each time in the sequence. So for the last one, it would have been plus 2, because we're adding 2 each time in the sequence. So now that we've talked about some of the logistics, let's go ahead and try a problem with this. Okay, so the first question says, an arithmetic sequence can be represented by the rule, and it gives us a rule, and they want us to find a sub 8 and a sub 12. So another way that you can say this is the 8th term and the 12th term, using that formula. So this is your general formula. This is an explicit formula. And what you're going to do with that formula is you're going to replace all of the n's with the term you're trying to find, which is 8. So this notation just means the 8th term. So we're just finding the 8th term. So 12 times 8 is 96. 96 plus 3 is 99. So this would just be 8th term is equal to 99. So does everybody see how I got that? Okay. So now we're also going to find the 12th term of the sequence. So you're going to plug in 12 for n. You're going to calculate it.
147.
Good, 147. So the 12th term is equal to 147. Now we're going to talk about how we could represent this rule another way. And the reason I want to mention this is there's going to be times where they give you a formula and they'll say which formula is equivalent to this one. So I just want you to be aware that they can be represented slightly differently. So if I rewrite the original formula, what do you notice about both of these terms in the formula? Yeah. You said factored, somebody say? Yeah, they can be factored, right? What can I factor out of them?
3.
Good, a 3. So technically, I could factor a 3 out of these, right? Oh, I forgot. Yeah, I forgot the 4. I'm like, wait a minute, that doesn't look right. 4n plus 1. Yeah, so I was able to factor out a 3. And these two are equivalent equations, right? Equivalent formulas. So if I would have used this formula, the second one we just got, to do the a and b, it would be, would it change anything about the, no. They'd be the same. So that's the idea here. These are what we call equivalent. Okay.
Is that how you start to write the recursive, or the explicit rule?
Yeah, you're on the, yeah, exactly. So we're going to talk about how, in the next question you'll see what I mean. So yeah, sometimes the rules are going to be represented and it doesn't look like the explicit formula, so you can actually go back to find the d and whatnot. So yeah, any questions on this so far? All right, let's go ahead and look at example 2. So they give us the arithmetic sequence can be represented using the rule a sub n is equal to 4 plus 5 times n minus 1. So in this particular case, okay, this is already in like the standard formula form, the form that you see on your sheet, okay? This one is explicit rule form. So it says find the first 3 terms of the sequence. So what am I plugging in for n for the first one? Yeah, 1. So if you want to find the first term, you're going to plug 1 in for n. And we're going to find the first term, which is known as a1. 1 minus 1 is 0. 0 times 5 is 0 plus 4 is 4. Then we're going to do the second term. 4 plus 5 times 2 minus 1. That's a2 is equal to 2 minus 1 is 1. 1 times 5 is 5. 5 plus 4 is 9. And a3. 4 plus 5 times 3 minus 1. That would give me A3 is equal to 14. So looking at these first three terms, what do you notice the common differences here?
Increased by 5.
Good. Increased by 5. Very good. So it's increasing by 5. And what do you notice the first term is? 4. Those are the two most important things you need to know about any sequence. If you know those two pieces of information, you can find any term in an arithmetic sequence. Okay? So, knowing that information, you'll notice here that the formula has those two numbers in it. The first term, A1, and the common difference, D. Just like if you look at that formula on your sheet right here under explicit rule, we have the A1 and the D. So they basically just took that formula and they replaced the A1 and the D. That's what we're going to be doing. So that's how the formula works. So now that we've done that, let's go ahead and find the 11th term. So we're going to just use the same exact formula, and we're just going to plug in 11 for n. And we get 54. So, pretty straightforward, I think. What do you guys think? Okay.
I just don't understand what this has to do with the explicit rule. Are we using that right now, or?
This is the explicit rule, but we haven't created one yet. We're going to create one on the next slide. Okay. So this time they gave you the explicit rule, and you had to find the terms. Sometimes they give you the terms, and you have to find the explicit rule. Alright, so let's go ahead and actually write the explicit rule this time. So now we're going to work backwards. Now we're given the actual terms, and we're going to find the rule. And not only do they want us to write the rule, they want us to write the rule in simplest form. So I'll talk about how that works as well. So on this question, you're given an arithmetic sequence. First thing of that sequence you always want to identify is what we call A1. And your A1 is your first term, which is what? 6. The next really important piece you want to find is your D value, which is your common difference. So, good, 10. Now, what if your sequence was going down? What would your common difference have been?
-10.
Negative, good. So it's positive if it's going up, it's negative if it's going down. Now, I'm just going to take the general explicit formula rule right from your notes. So this is where I'm getting at. I'm just taking it right from your notes. This is the general formula. So that's on the page before it. So I just took that explicit formula. And now, whenever you use that formula, you're always going to plug in two places, the A1 and the D. Those are the two spots you will always plug in for. So I'm going to rewrite this. A sub n is equal to A1 plus D times n minus 1. So those are the two things you always are going to plug into your explicit formula, the A1 and the D. Everything else stays as is. Now, this is the explicit formula, but it's just not in simplest form. So this is what we call the explicit formula, but not in simplest form. So to obtain simplest form, this is where the algebra comes in. We're going to use algebra to do this. So I'm going to use the distributive property right here. That's going to give me A sub n is equal to 6 plus 10n minus 10. And then from here, I'm just going to combine like terms. So my final answer is A sub n is equal to 10n minus 4. And this is what we would call our simplest form. And this formula, or the one before we simplified it, would help us find any term in this sequence. So you could plug in for n to find any term in this sequence. So does it make sense how to write a formula now? Okay. So let's try a few more of writing formulas to get some practice. So on B, what is our A1 going to be here? Good. And what would our common difference be? Good. 0.25. Now, if you are struggling to find out what the common difference is just visually looking at it, you can always take the second term minus the first term, which will always give you your common difference as well. So now we're going to take our general formula for the explicit formula, and I'm going to plug in A1, and I'm going to plug in D. So I'm just putting in different colors for the parts that we're changing in the formula, just to show you what we're applying to the formula. So this is the explicit formula, but it's not in simplest form. So in order to obtain simplest form, we would distribute here. We get A sub n is equal to 1 plus 0.25 n minus 0.25. And then, exactly, combine like terms. So our final answer is A sub n is equal to 0.25 n plus 0.75, because 1 minus 0.25 is 0.75. And this would be our simplest form of our explicit formula. Sure.
About the homework. Are we doing that thing that you said?
Okay. So, for letter C, let's go ahead and look at this one. So, A1 is what?
-1.
Good. And my brain. D. What? Good. -3. So, does everybody understand why it's -1 and -3 here? Yes, A1 is always the first number. Good question. So, now we're going to take our formula. A sub n is equal to A sub 1. And this time, it's going to be minus D, right, because it's negative, times n minus 1. And now to simplify, we just use the distributive property. A sub n is equal to 1 minus 3n plus 3. Combine these like terms. What's -1 plus 3? Good. So that will be our simplified version of the formula. All right. So how does everybody feel about writing explicit formulas? Good? Anybody need more time on any of these? All right. So let's move on to recursive. So we mentioned on the first slide, recursive rule is only useful to help you find a term after the one you already know. So what I want you to do, and I'm going to copy it down so you don't have to look back on your notes. This is the general recursive rule formula. A sub n is equal to A sub n minus 1 plus D. So that's the general recursive rule formula. Now, unlike the explicit rule formula, there's only one piece of information you actually can plug into a general recursive formula, and that is the D value.
Which is a change in the values?
Exactly, yep. Which is, in this case,
3.
Yep, positive 3. Yep, so the only thing you can do for a recursive rule is to come up with the D, which is the common difference if it's going up or down, whatever that is. And then you just rewrite the recursive rule formula, but you just replace the D value, that's it. Now that's all useful, but I want to just quickly explain how this formula would be used. So we said that, what do you remember a sub n minus 1 means?
Before.
Good, the one term before the nth term, right? So the nth term is the term you want to find. So this formula is only useful if you know the term before the one you're looking for. So in this case, we have 4 terms. So let's say we want to find the 5th term. So let's say we want to find a sub 5, 5th term.
You do 5 minus 1.
Good, and 5 minus 1 is
4.
4. So the formula would say, oh, well, you use a sub 4 plus 3. Well, what is the 4th term in this sequence?
10.
10.
Plus 3. Get 13.
Yeah. And that makes sense looking at the sequence, right? You would say the 5th term, which should be 13.
Mm-hmm.
So that's how the recursive formula works. It's only useful if you know the term before the term you want to find. So that's the idea. It can be useful at times when you don't have a lot of information. You can start collecting information from it, but it's not really an all-inclusive rule because it's not that useful. So let's go ahead and write the recursive formula for the next one. So I'm going to use the general recursive formula, which is a sub n is equal to a sub n minus 1 plus d. That's right from your notes. And the only thing I can plug into this formula is what? D. In this case, d is what? -5 is correct. -5. So does everybody see where the -5 came from? Yeah. That's just every time we're adding a -5 or subtracting a 5. Same thing. All right. So let's see what we have left. Oh, okay, not much. All right, continuing on. We're going to do some analyzing arithmetic sequences. So we want to determine if these are arithmetic sequences. The way you do this is check and see if there's something adding or subtracting each time that's consistent. So, yeah. So would you guys say example 5 is an arithmetic sequence?
So far, yeah.
Yes. And we can say that because D is equal to 4. Because we have a common difference that's consistent among the numbers. Any questions about that? Okay. So the next part is they're asking us to find the 46th term of the sequence. Now, you could sit here for like an hour, maybe not a whole hour, and try to figure this out. Or we can come up with, can you stop doing that? Thank you. It was going to be on the back of my video and then nobody would watch it. So, first thing we need to do is come up with an explicit formula, okay? So in order to come up with an explicit formula, we need to find the first term and the d value. So what is the first term in this sequence? Good. And what's the d value? 3. Any questions about where the a and the d came from? So now that we have that information, we're just going to plug into the formula. So the formula, explicit formula is a sub n is equal to a1 plus, good, 2 plus 3 times n minus 1. You got it. So this is the explicit formula I just plugged in for a, 1, and d. Now, you could simplify it, but you don't really need to, right? Because we're just trying to find the 46th term. So what am I going to be plugging in for n? Good, 46. And then we just do this calculation. 45 times 3. Yeah. 135 plus 2. I'm getting 137. So that's a faster way to find the 46th term without actually going through and keep adding 3 over and over again. So does that make sense to everybody? Alright, we have a few more things to talk about, and then you will have the rest of the period for work. I think 2 more things. So the next thing we're going to talk about is the arithmetic mean. So the arithmetic mean is basically when you have missing terms in the middle and you have to figure out what these terms are. Luckily, there's a pretty straightforward way to figure this out. So the easiest way to figure this out is take the larger number, subtract away the smaller number that you know, and do that calculation. And I get 45. And then you're going to take that number and divide by the number of spaces plus 1. So what would that be? 3. So it's always number of spaces plus 1. That's always what you're going to divide by. And when you do that division, you get 15. 15 is known as your common difference. Okay, so that's a way to find your common difference. Now once you have your common difference, all you have to do is add it to your first or subtract it. In this case we're going to add it because they're going up. Everybody see why we're adding it this time? Okay, so you take 80 plus 15, that's 95. And then how would I get the next term?
Add 15.
Good, add 15 one more time. And I get 110. And if you want to check your work, you can add 15 one more time to make sure that it's, the number that we have there, which it is. So any questions about finding the arithmetic mean? Alright, let's try the next one. Everybody good with example 7? Alright, so the next one, what do you notice about, in this case, it goes
Backwards.
Yeah, it goes backwards. So I personally still like to do the larger minus the smaller. You can do it the other way around, but instead you're just going to add instead of subtract. So it's really up to you. I take the larger minus the smaller still. And I get 34. And what am I dividing 34 by this time? Good. Dividing by 2. Everybody understand where the 2 came from? Number of spaces plus 1. And I get 17, which is my common difference. Now that I have my common difference, I need to apply it. Now am I going to be subtracting it or adding it? Good, subtracting. So you're going to subtract 17.
I mean, you could do both ways if you add from the 98, right?
Exactly. Good job. Yep. You got the idea. And if you subtracted the other way around, you would have got a negative, and then you could have added the negative. So there's a lot of options. And then you can subtract 17 again to make sure you get 98 as well. So do I have any questions on the arithmetic mean? Okay. So I also want to mention, in a sequence, say this is our first term, or they may call this the a sub n minus 1 term, which would make this the a sub n, which would make this the a sub n plus 1. So I mention that because sometimes they'll just say a sub n minus 1 is equal to 132, and you have to line them up yourself. And if you want, at the end of class, there is a homework problem like that, and I'm happy to do it with you guys, so let me know. So yeah, we have one more thing, and then you'll have homework time. Can I see? Yes, sorry, Angela, I just saw that, but I can go back and put that up at the end. All right. You're welcome. So the next problem we're going to do is going to be a arithmetic sequence word problem. So it says the number of seats in the first 16 rows of an arena form an arithmetic sequence. If row 1 has 20 seats and row 2 has 23 seats, how many seats are in row 16? So our first term in this sequence is actually what?
20?
20. And our second term is 23. And we know that it's in the pattern of an arithmetic sequence because they tell us it is. So because they tell us that, we can assume that it goes in that pattern. So our A1 is what? Well, we just kind of said it, 20. And our D value is what? 3, positive 3. Now that we have that information, we can come up with an explicit formula. A sub n is equal to your A1 plus your D times n minus 1. And now that we have that information, how can we use it to find the number of seats in row 16? Good, plug in 16 for n. Good job. So we are going to plug in 16 for n. We're going to solve. And we get 65. So there are 65 seats in row 16. Make sense? Alright, so why don't you guys get started on the homework. But one thing I want to mention before you do, real quick. So up on the board, we're going to talk about geometric sequences in the future, but I want to just briefly mention them. So, what do you notice the pattern for this sequence is?
It's multiplying by 2.
Multiplying by 2 each time, right? So, since it's multiplying by 2, this is not an arithmetic sequence. Just because it has a pattern doesn't mean it's arithmetic. Arithmetic has to be addition or subtraction each time. This is multiplication. Multiplication and division are what we know as geometric sequences, which we'll talk about in the future. But I just want to mention that on the homework there is a geometric sequence that comes up, so it is not an arithmetic. So not every pattern is arithmetic. Alright, you can get started on the homework. Let me know if you have questions.
Could you go to example 4?
Yes, somebody else needed that one too. 4B. I think I just skipped it, huh? Here's 4B for anyone who needs it.
Oh, there's last night. Okay, my mom had yeah, so basically she's like,
You may.
and I'm just like,
Let's see. I may have regular pens over there.
Oh, wait, no, I have a pen. Sorry, I forgot.
You do have one?
Yeah.
Okay. Yeah, I can show you example 6. So due dates. Anybody in here need to know about due dates in my class, how to submit all that stuff?
I do.
Alright, I'm going to go over that in just a second. Angelo, are you good with example 6 or you need it real quick? So take this down if you need it, and then I'll talk about due dates in like 2 minutes. So Mia, I'll talk about due dates in just a second when he's done with example 6. Oh, okay, you're good then? Alright, so if you're new to my class, you're going to want to listen to this. If you're not new, just be quiet so I can talk about it with everybody else. So, if you're in this class new, first thing you want to do is kind of familiarize yourself with my eCampus page. So you're going to, oh my gosh, I forgot I have to still my video.